Hi everybody, welcome to the Kentucky 4-H virtual experience. Today we're going to concentrate on SET or Science, Engineering, and Technology programs. My name is Torey Earle and I am an Extension Specialist for 4-H Youth Development with the University of Kentucky College of Agriculture, Food and Environment Cooperative Extension Service. The activity we're going to do today comes from the 4-H Electric Excitement Curriculum, Book 1, The Magic of Electricity, and it's called Is There a Fork in the Road? In this activity, you will learn a little bit more about how electricity flows in a circuit and different types of circuits, including series and parallel circuits. As we talked about in one of our previous activities, a circuit is a complete flow of electricity from positive to negative. In order for electricity to do work, it has to flow in a complete circuit. But sometimes those circuits have to branch off. And the two types we're going to look at today are series and parallel circuits. In a series circuit, the electricity flows directly from positive to negative all the way through the circuit. It never branches to a different area. But in a parallel circuit, the circuit itself may branch. And each one of these circuits is used for different purposes. And we're going to look at each one of them today and how they react. The supplies that you'll need for your activity today with series and parallel circuits: you will need a couple of D-cell batteries and a couple of D-cell battery holders. You'll also need 2 lamp sockets for 1.5 volt lamps. You'll need the 1.5 volt lamps themselves to go into the lamp sockets. And you'll need either some copper doorbell wire, which you see right here, but for convenience sake today, I'm going to use wires with alligator clips on them so I can connect and disconnect them quickly. These items can be found at local hardware stores, or you can order them online. They're relatively inexpensive. The whole setup that I've got here is probably about $6. So if you choose to use the doorbell wire, it's going to be even less expensive than using the wires with the alligator clips, but you will also need to have a small screwdriver to loosen and tighten the screws on the lamps. As we start today, we're just going to look at the most basic of circuits. 1 battery, 1 bulb. And in order to get the bulb to burn, we'll connect the positive lead of the battery to one side. I'll just touch it to the one side, and the negative lead to the other, and the light burns. This shows that electricity is doing work. It's traveling through or from the battery through the light bulb, providing it electricity, and then coming back into the negative side of the battery. That's the simplest of circuits. In our second circuit we're going to look at today, we're going to use 2 batteries, 2 bulb holders with bulbs, and in order to get the bulbs to light up, we're going to have to make sure that our circuit connects from the positive side of this battery into the bulb, through the bulb to the second bulb, from the second bulb back to the negative side of battery number 2, and then that the 2 batteries are connected together, positive to negative. Doing this, I'm going to use the alligator clips to, again, make it a little more convenient, a little quicker to hook up. So my first thing to do is take one of my alligator clips to the positive side of battery number 1. Then I will clip it to a terminal on bulb number 1. From bulb number 1, I will clip an alligator clip to the second terminal on bulb number 1 and to the first terminal on bulb number 2. This is starting my circuit. I'm going from positive into the bulb, through the bulb, to the second bulb. I'll take my alligator clip, clip it onto the second terminal on bulb number 2, and then I will connect it to battery number 2. Now, we still don't have a complete circuit because these two leads, positive on battery number 2 to negative on battery number 1, are not touching. So let's move our light bulbs back a little bit and touch those two together and see what happens. And we have two lights lighting up. So we have a complete circuit. What I'm going to do to hold these together, I'm going to use another alligator clip. I'm going to clip it just like that, so it holds those two wires together. Now, this is a series circuit. Electricity flows from positive all the way through the circuit back to negative. There is no branch in this circuit. But one of the unique things about a series circuit is if I remove one of the bulbs, the whole circuit goes out because electricity is no longer flowing in a complete circle. But I put the bulb back in and it works again. Series circuits are used for various things, but probably one of the most common ones that they can be used for are holiday lights. If you take one bulb out of a strand of holiday lights, all of the bulbs go out. Put it back in, it completes the circuit again, and the bulbs work. So that is an example, a real-life example of a series circuit. Our next example, we're going to have two bulbs, one battery, but each one of the bulbs is going to get the same amount of electricity flowing through it. And this is called a parallel circuit. In a parallel circuit, electricity will branch off from a source. So we're going to need to clip one of our alligator clips to the positive side of the battery and one terminal on the bulb, and we'll need to clip another alligator clip to the second terminal on the bulb and to our battery. And you see that the light bulb burns. Now, how do we get the other light bulb to burn? We're going to make a branch off the circuit. So I'm going to clip to the positive side of the battery and to terminal 1 on the bulb. And I'm going to clip to the negative side of the battery and to the second terminal on the second bulb. And I have two lights that burn. If you remember in the series circuit, if we took one of the light bulbs out, it broke the circuit or it disconnected the circuit, so it would not work anymore. Let's see what happens if we take one of the light bulbs out for the parallel circuit. The other light bulb remains burning. That's because it is still in a complete circuit. The second light bulb has a branch off of the battery itself. So light bulbs will continue to burn, or everything will continue to work if one part of that circuit goes out. If one branch goes out, the other branch still works. This is a parallel circuit, and it is used very, very commonly in wiring houses and structures, because you don't want a circuit to go out or all of the lights to go out, or all of the electricity to go off just simply because one thing in the circuit quits working or has a disconnect in that circuit. So series and parallel circuits used for different things, and this is an example of how each one of them works. The last circuit I want to build in this activity is going to involve two batteries, two bulbs, but we're going to run from positive to one terminal on the bulb, out to the negative of the other battery, from the positive of this battery to a terminal on this bulb, and from this terminal back to the negative of the battery. We're going to see what happens when we do it. So first, clip on to the positive of the battery 1, clip on to terminal on bulb 1, come out of terminal 2 on bulb 2, or bulb 1, excuse me, to the negative terminal on battery 2. From battery 2, I will clip on to positive terminal, terminal on bulb 1, bulb 2, excuse me, second terminal on bulb 2 to our battery. What do you predict will happen if I remove a bulb? Do you think it will continue to burn, or our circuit will go out? So what kind of circuit is this? Series or parallel? If you said series, you are correct, because if one part of the circuit is removed, the entire circuit does not work. What you see here is a visual representation of the two different types of circuits we talked about today, the series and the parallel circuit. You have power source, positive, going to a switch. When the switch is connected, electricity will flow into one lamp, from one lamp out to the second lamp, and from the second lamp back out to the negative of the battery. In the parallel circuit, positive electricity will flow out to the switch. Switch is connected, will flow into one light bulb, but you see here it has a parallel line that will go to the second bulb. So if this one was removed, the second bulb would still work. Parallel line connecting the negative to the negative, back to the negative of the battery. So this gives you a visual representation of what each of the circuits would look like in a little cleaner manner than we did with our alligator clips and batteries. Putting them together gives you a better idea of how they work. So this, you can see what they look like. What we did with our hands-on is putting them together to see how they work. Well, how did you do? Series and parallel circuits. You've had a chance to see how both of them work. You've had a chance to build both of them, and you've learned a little bit more about what each one is used for. As you would go through more of the electricity activities we're going to do, keep in mind that electrical safety is important. Before testing a circuit, please make sure that the circuit is disconnected from a power supply. Now with our batteries, the voltage is relatively low, so you run a very, very minimal risk of shock with that. But if you would work with a higher voltage circuit, say a 120 volt circuit like you would have in a house, you want to make sure that you disconnect or cut the circuit off before you would start working on it. I hope you've enjoyed doing the activity today on series and parallel circuits, and we look forward to working with you again on some more electricity activities in the future. Thank you for joining me today. for the Kentucky 4-H virtual experience focused on science, engineering, and technology. For more information about the 4-H SET program, please check out your local University of Kentucky Cooperative Extension Service.